Okay, today's topic is optimization. In calculus, the main application questions are from optimization. We'll divide this one into two parts. Part 1, we'll do some problems. Part 2 will be some business questions. It's very difficult to cover every optimization question. So what does to optimize mean? To optimize means to get the best possible outcome. To optimize means to get the best possible outcome. So we use maximum and minimum concepts to optimize. What do we optimize? We can do maximum volume. We want to have maximum profit. We want to have minimum cost. We want to have maximum revenue. No one wants maximum cost. The steps we follow will be: we identify first the quantity to be optimized and write a formula for it. If the right side in the formula has two variables, I have to find another formula and then isolate one variable in terms of the other one. Then I substitute into the main formula. I find domain and range domain where possible. Then we do the derivative and we follow the concepts of maximum and minimum. So let's see typical example for optimization. A box with an open top is made of 80 centimeters side. It's a square. We cut the corners as squares. We have 4 corners, so its length is x and x, x and x. So the side length of the box will be 80 minus 2x, 80 minus x minus x. Therefore, since it's a box, the volume will be length times height times width. Our height is x. Therefore, 80 minus 2x, 80 minus 2x, which is the same as x, 80 minus 2x squared. So we expand this one here. By expanding this one here, we'll get 6400 x minus 320 x squared plus 4x cubed. Once we have the volume, we derive dv. The volume will be, the derivative of that will be dv dx, derivative in terms of x, which is 6400 minus 640x plus 12x squared. Once we find the derivative, we make this equal to 0. Remember, our domain will be only the numbers which make the side a positive number. Therefore, 0 less than or equal to x less than or equal to 40. We cannot have 0 and 40, of course, it will be a 0. It will not be a flat. Therefore, it should be numbers between 0 and 40. So, to derive this one, we derive that. And then we make it equal to 0. I can divide all by 4. So, this will be 1600 minus 160x plus 3x squared. We divided all by 4 because it's equal to 0. So let's write it like 3x squared minus 160x plus 1600 equal to 0. At this point, we factor or we use a quadratic formula if you cannot factor. So we can factor here. It will be 3x minus 40 and x minus 40 equal to 0. So when we factor that, we get two factors and we solve those ones, which means x equal to 40 over 3, which is 13.33, or x equal to 40 we have already in the domain. So our value will be x equal to 13.3. So now what are the dimensions? The dimensions will be x is 13.3 centimeter, and then the other one will be 80 minus 2 times 13.3, 80 minus 2 times 13.3. Dimensions are 3. So for 13.3 centimeter by 53.4, 3.4 centimeter by 53.4 centimeter. These are the dimensions to give me a maximum volume for this box. Okay, this is the first type of questions. Let's do a second type of questions. A schoolyard has 2400 meters of fencing to enclose 4 equal rectangular areas for different age group students to be a playground. What is the largest area that can be enclosed? What is the largest area that can be enclosed? So our question is, we are given a rectangular thing which are 5, which we will expect 5 sides here. So 1, this is that, and then we divide this into 4 equal parts. 1, 2. So we have 4. So 1, 2, 3, 4. So let's see, the length of this is y, the length of this is x, the length of this is x, x, and x. So what are we optimizing? We are finding the largest area, which means maximum area. Therefore, the formula for area will be, from here to here will be 1, 2, 3, 4, 4x times y. So this is the area of the whole plot. Then we have 2 variables on the right side, so we need another formula, which means we are given the perimeter, which is 2400. So the perimeter is 2400 equal to 1, 2, 3, 4, 5. 5 y's. Vertical lines are 5 plus 4x here and 4x here, which means 8x. So now we can isolate one term in the other one. So we have 2400 minus 8x equal to 5y. Therefore, y equal to 2400 minus 8x over 5. I take this value of y, I substitute onto the y into original equation. 2400 minus 8x over 5. I simplify this, which is 9600 x minus 32 x squared over 5. Then my next step is, since we have this, we always derive. So derivative, I can write it sometimes a prime x. I derive the top, since the denominator is a number, it will not affect my derivative. The top will be 9600 minus 64x over 5, which will not affect my equation. Therefore, 9600 minus 64x equal to 0. Therefore, from this one, as x equal to 150. So now, what is the maximum area? I have to find x, I have to find y. So from this one here, y will be 2400 8 times 150 over 5, which is equal to 240. Therefore, what are my dimensions? My dimensions will be 4x this side and y this side. Therefore, the dimensions will be 4 times 150, which is 600, and y will be 240. Therefore, 600 by 240. So the maximum area, I multiply these two, 2400 times 6, which is 144. 144, 123 centimeter square. Okay, that's for this question here. So the last question on this section we'll have about a cylinder. A juice company makes juice cans with a volume of 600 milliliters. What dimensions will minimize the amount of material needed to make them? Amount of material means surface area, so we have to minimize surface area. To minimize surface area, first let's see 1 milliliter. What does it mean? 1 milliliter is 1 centimeter cube. 1 liter is 1000 milliliters and 1000 centimeter cube. Okay, so let's see surface area. What is the formula for surface area of a cylinder? Since it has two circles, top and bottom, it will be 2 pi r square plus 2 pi r h. We have two variables on the right side, so we need another formula, which is the volume, which we are given the volume, pi r square h. Therefore, we know the volume is 600. 600 equals pi r square h. So h will be 600 over pi r square. Now we substitute this one into our surface area. 2 pi r square plus 2 pi r, 600 over pi r square. Then we have 2 pi r square. We simplify that, plus I cross out the r with the r, the pi with the r, so it will be 1200 over r. Okay, so we have that. Once we have surface area, we derive this one. Surface area, derivative of that, I can say surface area prime. The derivative of that will be 4 pi r. Derivative of 1 over r is minus 1 over r square. So 1200 over r square. This must be equal to 0. I multiply all by r square. So it will be 4 pi r cube minus 1200 equal to 0. 4 pi r cube equal to 1200. Therefore, r cube will be 1200 over 4 pi, which tells me r is the third root of 1200 over 4 pi. I calculate this, I get 4.57 centimeters. I substitute this into my h, which is 600 over pi 4.57 square. This will be 9.14 centimeters. So if my calculations are right, for this kind of questions, to maximize volume, always the height must be equal to the diameter, which means the radius must be always half of the height. So my dimensions for this are dimensions, we say r is 4.57 centimeters, h is 9.14 centimeters. Okay, that's some kind of questions with optimization.